we'll just go over basically a short intro to solution writing. So as you may notice, the JPOMO finals includes two questions that will require you to write full solutions. And we at JPOMO believe that uh, introducing solution writing early is important because, for one, communicating your ideas is an important skill in a lot of areas in life, and number two, um, you will encounter proofs and solution writing in general as you go to higher level contests or basically higher math in general. So yeah, let's go through this. Before I show what we would expect from a solution, I'm going to ask you guys this first. Say you were given two proofs that that of the statement, the sum of two even integers is even. Which of these solutions would you rather read and why? So these are the two solutions. The the more important question actually here's the why, because I want to see what you guys think are ideal standards of what a good solution looks like. I'll just wait a few minutes. It would also be helpful if you guys state uh why you would rather read one. Um because I want to see what you guys think are what you guys think are ideal of characteristics of a good solution. So yeah, I'll give maybe one more minute. Okay. Um it seems that we kind of have a unified answer here. So basically everyone prefers to read chubby solution more. Um I'll point out some obvious flaws with Penrick's solution first. Firstly, it's not that legible. If you may notice, there are also a lot of um, erasure marks somewhere, and there's also like a lot of wrong spelling, like number and because and things like that. And it's not that organized in the first place, compared to Chubby Solution, which is very organized. And yeah, so firstly, I want you guys to keep in mind that when you write solutions, someone else is going to read your work. Um, Especially that is a contest. Since you are writing solutions as a submission for a contest, it is usually fine to write just enough so that the grader can understand your work. So your goal in writing the solutions, at least for this contest, is to convince us that you know how to solve the problem fully. And by solving the problem fully, I'll talk a bit more about that later on. So first, I'll state the obvious. Be very clear with what you're trying to do. So of course, write legibly. And we would also prefer that you guys write in sentences, because if you just write equations, then it's kind of easy to get lost with the crazy amount of symbols that's there. So So we would prefer that you guys write in sentences so that the flow of the proof is also natural in a sense. However, if you are running out of time, then it would be okay to not write a few parts in sentences, um, especially in equations. What I would like to do uh, is to just put some implications using the imply symbol. Hold on. Is to just use the imply symbol, the one that looks like the following. This one. Or something like that. So essentially you have a statement here, then another statement here. So if you don't really have that much time, you can just do that. That would also be fine, but as much as possible, please write in sentences because that writing in sentences is the best way to uh, explain your ideas. And please clearly define any new variables or terms that you'll use in your solution. So for example, don't be too vague. The best possible way to define it is to be as specific as possible so that A and B be even integers is better than let A and B be two numbers. Or but if you just want A and B to be two real numbers, then that would be fine. But it would also be better if you specify that A and B are two real numbers instead of just numbers. And the worst possible case is to completely omit this because in your solution, if you pull out A and B without stating what they are, then how would we possibly know what those are? Okay. So as you can see, Chubby did that very well. He stated here that A and B be even integers, and then proceeded with a proof based on that. And you should also explain your reasoning well. Note that if we ask you to prove or show that a statement is true, then you should give basically a full explanation on why the statement is true. It is not giving examples that support the statement. So, for example, this is also why Penchick's proof is wrong, and it's not even counted as a proof. So he just wrote the examples here, 2 plus 2 equals 4, 2 plus 4 equals 6, and so on. But this is not a proof. Why? Because what about the other possibilities? He didn't consider like the quote unquote proof here doesn't consider the case of, let's say, 62 plus 64. Is it also even? And things like that. However, if the question asks you to prove that something exists, then it's fine if you just give some examples, as long as you show that the examples indeed satisfy the conditions. So, for example, if we have a problem here, prove that there is a natural number that is divisible by both 2 and 3. Obviously, you can think of one at the top of your head already. Um, this would already count as a complete proof. So first, you could state the said example, we claim that the number 12 is a natural number divisible by both 2 and 3, and then state why it satisfies the condition. So since 12 over 2 is 6 and 12 over 3 is 4, and these are both integers, we conclude that then you just state the conclusion again. And of course, proofs for actual problems will likely be much longer than this. Oh, also, please write correct math. One small mistake um, can entirely trip up your entire solution. If you still have remaining time in the contest, it is always worth it, and I highly recommend that you go through your solution and check if you have any typos or logic gaps or anything, um, and that everything you wrote is completely correct. So I saw that this has already been mentioned in the chat, but Penchick also fell for this and put 8 plus 8 equals 67, which is obviously wrong. And note that since 67 is odd, it doesn't even satisfy the condition. And And so that would already disrupt his entire proof, even though it is not even a proof. So with this, if this were true, then then what is being asked is not true in the first place. And an even more common mistake is writing the proof backwards. What do I mean by that? The proof goes from what is being asked to something that we know is true. You should not do that because if A then B doesn't always mean if B then A. And these statements are called converses of each other. An easy example of this is we know that all squares are rectangles, but not all rectangles are squares. Yeah. So for example, we have this problem. Prove that for positive numbers a and b, we have a plus b over 2 is always greater than or equal to the square root of ab. Some of you may recognize this as the two variable version of the AMGM inequality. I'll show first the wrong proof. So notice that it starts with multiplying both sides by 2 gives this. Notice that this one comes from here. Another way to think about this is why are you using the the statement here when you don't know that it's true? So essentially, this entire proof is wrong. Something like that. The correct proof is the version of this that is written in the other direction, which is this. It starts with something that we know is true and then builds up from there and ultimately ends up with what is being asked. So since the square of any number is non-negative, we have this, and then after some line of reasoning gets to this one. Yeah. And some other types of problems. Yeah. If the problem asks you to find all objects that satisfy a certain property, uh, you must first state what these objects are. Then second, show that they satisfy the property. Please remember not to leave this out because it is still an important part of the solution, even though it might be very easy. And third, show that there are no other objects that satisfy the property. Similarly, if the problem asks you to find a minimum or maximum value of something, then first state the answer. Second, show that this value is attainable. Note that if it's not attainable, then it isn't even a possible value of the quantity. Then third, show that there cannot be a value lower than if asked for a minimum or higher than if asked for a maximum. Your answer. So essentially show that what you have is indeed a minimum or maximum. If you forget these points, don't worry. The proof questions in the actual contest will include these as a guide. For more comprehensive tips, you can check out this handout, which is also linked in the sample problems as a resource. And additionally, the sample problems document has a handout version of this presentation that you can also check out for your own reference.